Hi everyone, I will discuss the laws of exponents. But first, exponents tells us how many times the base or number is used as a factor. It is also called as power or indices. Law number 1. Product of powers. Product is the answer in any multiplication problem. When multiplying powers with the same base, add the exponents. Examples: a raised to 9 times a raised to 8 equals a raised to the power of 9 plus 8 equals 17. Since they have the same base, you can add the exponents 9 and 8 to have the answer a raised to 17. Number 2. 2b squared times 2b to the fourth power times 2b equals 2b raised to 2 plus 4 plus 1 equals 2b raised to 7. These also have the same base, so you can add their exponents 2 plus 4 plus 1 equals 7 and copy its base 2b to have 2b raised to 7 as your answer. Note: when a term or base doesn't contain an exponent, automatic it is counted as 1. Example: x equals x raised to 1. Next, 2 equals 2 raised to 1. And lastly, b equals b raised to 1. Number 3. C cubed times c squared times b to the fourth power equals c raised to 3 plus 2 b to the fourth power. You can only add the exponents of the terms with the same base. C cubed times c squared. You can add the exponent 4 because its base b is not the same as c. Law number 2. Power of a power. To raise a power to a power is simply multiply the exponents. Examples: a squared all raised by 4. Simply multiply the exponents. 2 and 4 equals to 8 to have a product of a raised to 8. Number 2. A plus 1 squared all raised to 3. Leave the terms in the parentheses as is and multiply its exponent 3 and 2, which is equal to 6. Number 3. 2 cubed all raised to 2. You will be distributing the exponent 3 times 2 equals to 6 to have 2 raised to 6 and simplify into 64. Law number 3. Power of a product. To find the power of a product, find the power of each factor and multiply. Think of it as distributing the exponent to each factor. Factor are the numbers you multiply together. Examples: negative 3a all raised to 2 equals 9a squared. Raise each factor to its power. Negative 3 and a will be raised by 2 to have the product of negative 3 squared and a squared, or 9a squared. Number 2. Negative 3x cubed y squared z all raised to 3 equals negative 27 x to the 9th power y to the 6th power z cubed. Raise each factor to its third power. Negative 3x, y, and z is all raised to 3 to have a result of negative 3 cubed x to the 9th power y to the 6th power z cubed, or negative 27 x to the 9th power y to the 6th power and z to the 3rd power. Number 3. 2xy all raised to 3 equals 8x cubed y cubed. Distribute each exponent to each factors. 2, x and y is all raised to 3 to make it 2 cubed x cubed y cubed, and simplified into 8, x cubed y cubed, x cubed and y cubed can be simplified because they are not the same. Law number 4. Quotient of powers. When dividing powers with the same base, subtract the exponents. Examples: a to the fourth power over a squared equals a squared. They have the same base as a, so you can subtract their exponents 4 and 2. Number 2. X to the seventh power times y to the fifth over x times y cubed equals x to the sixth power times y squared. Deal with the same bases. First, x raised to 7 minus 1 equals x raised to 6. Then next to y raised to 5 minus 3 equals 2. Therefore, you will have the answer x to the 6 y squared. Number 3. C raised to 10 over C raised to 8 equals C raised to 2. Subtract its exponents. 10 minus 8 equals 2, and keep the base C for you to have C raised to 2. Law number 5. Power of quotient. Exponential is being divided and raised into a power. Examples: 3x over 4 raised to 2. Raise each factor to its power. 3x and 4 should be raised by 2 to have 3 squared x squared over 4 squared, or 9x squared over 16. Number 2. B squared over C all raised to 2. Distribute each powers. B squared and C will be raised in 2. So the final answer will be B to the fourth power over C squared. Number 3. 2 over 3 raised to 4. Distribute each power. 2 and 3 will be raised in 4. To make it 2 raised to 4 over 3 raised to 4, and should be simplified as 16 over 81. This has been a project in mathematics. Thank you for watching.